Welcome to Edupedia World. In this video, we will discuss about methods of measuring dispersion. There are certain specific measures which help in determining the deviations from central value. These are known as measures of dispersion. The main measures are absolute measures of dispersion and relative measures of dispersion. The classification of absolute measure of dispersion are range, quartile deviation, interquartile range, mean deviation, standard deviation, and Lorenz curve. And classification of relative measures of dispersion, coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, and coefficient of standard deviation, coefficient of variation. All these measures we will discuss one by one in our coming slides. First, we will discuss range and coefficient of range. It is an absolute measure of dispersion. It is simple measure of dispersion. It is defined as the difference between the largest value and the smallest value in a distribution. Symbolically, range, which is denoted by letter R, is equals to largest item, denoted by letter L, minus smallest item, denoted by letter S. For example, if the marks received by students of 11th class are arranged in ascending or descending order, then the range of marks will be difference between the highest and lowest mark. A larger value of range indicates greater dispersion, and the smaller value of range indicates lesser dispersion among the items. If all the items are the same, range will have a value of 0. That is, there is no dispersion between the items. As range is a measure of absolute dispersion, it cannot be usefully employed to compare the variability of two distributions expressed in different units. For example, if amount of dispersion is measured in rupees, then it is not comparable with the dispersion measured in inches. In such cases, we need a relative measure, that is coefficient of range, which is independent of the units of measurement. So next we come to coefficient of range. It is a relative measure of dispersion. It is used to compare variations of two series or distributions expressed in different units. It is defined as the ratio of the difference between the largest value and the smallest value to their sum. Symbolically, it is written CR is equals to L minus S divided by L plus S, where CR means coefficient of range, L means largest value, and S means smallest value. Coefficient of range is a relative measure of dispersion. The difference between range and coefficient of range. Range is an absolute measure of dispersion. So if we want to compare the variability of two or more distributions with the same unit of measurement, we may use range. Whereas coefficient of range, it is free from the units of measurement. If we want to compare the distributions given in different units, we make use of coefficient of range. Now we come to calculation of range and its coefficient. First, in individual series. There is no frequency in individual series. We are just given the values of the variable, which is denoted by letter X. We need to arrange the series into ascending or descending order. We need to recognize the largest and smallest values in the distribution. Let us understand this with the help of a following illustration. We have to calculate range and its coefficient from the following data. For the solution, we need to arrange the data in ascending order. For that, we will make a table of two columns. In the first column, we will write serial numbers, that is 1, 2, 3, 4 and 5. And in the second column, we will write the data which is provided to us, that is x, in ascending order. We'll start with 45, 65, 70, 80 and 90. As you can see in the table that the largest value is 90. So we will write 90 in front of largest item and smallest item is 45. First we will calculate range. R is equals to L minus S. L is 90 here and S is 45. So after deducting 45 from 90 we will get 45 as a range. Next we will calculate coefficient of range. We will write the formula, that is CR equals to L minus S divided by L plus S. After putting up the values we will calculate it and we will get 0.3 as coefficient of range. This is how we will calculate range and its coefficient in individual series. Next we come to calculation of range and its coefficient in discrete series. There is corresponding frequency given against values of variable x, x being a definite value in the series. We need to arrange the series into ascending or descending order. We need to recognize the largest and smallest items in the distribution. The frequencies of concerned variables are not to be taken into account. Let us understand this with the help of a following illustration. We have to calculate range and its coefficient from the following data. In the data, x and its frequency are provided to us. For the solution, we will first arrange the data in ascending order. Data is already arranged in ascending order. So we will write the largest item, that is 20, and the smallest item, which is 12 in this particular illustration. First we will calculate range, that is R is equals to L minus S. 12 will be deducted from 20, we will get 8 as a range. Next we will calculate coefficient of range, that is CR is equals to L minus S divided by L plus S. After putting up the values we will calculate it and we will get 0.25 as coefficient of range. As we have seen that the frequencies of concerned variables are not to be taken into account. This is how we will calculate range and its coefficient in discrete series. Next, we come to calculation of range and its coefficient in continuous series. There is corresponding frequency given against values of variable x, x being in the form of class intervals. We need to arrange the series into ascending or descending order. We need to find out the largest and smallest items in the distribution. The frequencies are to be ignored as range is determined by two extreme observations. There are two ways to calculate range and its coefficient. First, by using lower limit of first class interval and upper limit of last class interval. And second, by using midpoints of first class interval and last class interval. We can use any one of these methods, but we will discuss both the method in the coming slides. In this particular illustration, we have to calculate the value of range and its coefficient. We will discuss both the methods to calculate range and its coefficient in continuous series. First method, by using lower limit of first class interval and upper limit of last class interval. As you can see in the table that lower limit of first class interval is 20 and upper class limit of last class interval is 80. So largest item L is equals to 80 and smallest item S is equals to 20. So first we will calculate range. R is equals to L minus S. So 80 minus 20 we will get 60 as range. Next we come to coefficient of range. CR is equals to L minus S divided by L plus S. After putting up the values and calculating it, we will get 0.6 as coefficient of range. This is how we will calculate range and its coefficient by method 1. Now we come to second method, that is by using midpoints of first class interval and last class interval. Alternatively, we use midpoints to find range and its coefficient. For that, we will make a table of 3 columns. In the first column, we will write wages, that is X, 20 to 30, 30 to 40 and so on. In second column, we will write mid values, which is denoted by letter M. So mid value of a class interval 20 to 30 is 25. Next is 35, mid value of 30 to 40, and so on. We will write the mid values of the particular class intervals. And in the third column, we will write number of students, that is frequency, which is given in the question. After getting the mid values, the mid value of first class interval is 25. So it's the smallest value. And the mid value of last class interval is 75. So it's the largest value. So first we'll calculate range. Range is equals to L minus S. Here L is 75 and S is 25. So we will deduct 25 from 75. We will get rupees 50 as range. And next we will calculate coefficient of range, that is CR, which is equals to L minus S divided by L plus S. After putting up the values and calculating it, we will get 0.5 as coefficient of range. Here you have seen that we get different answers by using the two methods, but both the answers are taken as correct. You can pick up any one of these two methods according to your convenience in calculating range and its coefficient in continuous series. After discussing methods of calculating range and its coefficient, now we come to the merits of range. First, it is rigidly defined. Second, it is easy to calculate and simple to interpret, as we need to know only the two extreme values. Third, it depends on the units of measurement of the variable. And the last merit is that it is widely used in statistical series related to quality control in production, changes in rates of interest, changes in rates of foreign exchange, etc. These are some of the merits of range. There are some demerits also. Demerits of range. First, it does not depend on all values of the variable. In other words, range does not take into account the distribution of values between the smallest and largest values. Second point, it is unduly affected by extreme values. In other words, a single variation in extreme value would affect the range. Next point, it cannot be calculated in case of open-end class intervals, as extreme values are not known. Next point, it is very much affected by fluctuations of sampling. And the last point is, it does not reflect the pattern of distribution of the series. So these are some of the demerits of range. Though there are some demerits of range, but it is useful in many cases. Let us discuss the uses of range. First point, useful measure to study fluctuations. Fluctuations in the price of common items and shares are studied effectively through range. Second point, day-to-day living. Range is a useful measure of variation in our daily life. For example, while purchasing ready-made garments, we generally ask a shopkeeper about the maximum and minimum price of garments. Third use, quality control. Range plays a very important role in preparing quality control charts. If the quality of the product remains within this prescribed range, then quality is under control. Fourth use, for weather forecast. The meteorological department makes use of range in forecasting weather condition, humidity level, rainfalls, etc. These matters are of great public interest. So these are some of the uses of range. So we can say that range and its coefficient is a very important method in measures of dispersion. Thank you for watching Edupedia World videos.